Hello everyone, so today we will be implementing a simple data structure which is a set with a TDD style. We will discuss some good and some bad practices for TDD, and we will see some of those that breaks the three laws of TDD introduced by Uncle Bob. You could just, if you don't know it, you could just search for it, Google it. You just type three laws of TDD and you would find it right away. Okay, so TDD is a discipline that enables us to build a high quality software. The idea behind is driving the production code by writing tests. We would start by creating a test, failing in that test, writing production code, doing refactoring, and do the cycle moreover till the end. So to start, I'll be creating our test class, which I would name. Let's name it TDD set should. Okay, I'll create my class to start TDDing, and I'll create an attribute that is TDD set, the class that you would like to create. And right here we have a compiling error saying that we don't know yet the TDD set. I start by, let's say, creating this TDD set class. Okay, I will choose to make it in the main repo. I will create it right now, and like this we just made our first cycle of TDD. We will create just a dummy test that would say we write it everything well, so I would execute it and it should pass successfully. Okay, takes time to run. Great, so it's working. Okay, so right here we would like our TDD set to be a real implementation of set. We would use it in a real production code. So we assume that this set, we would like this set to be to implement the real set interface. So for that we will create our first test, which should be, let's say, it should implement the set interface. Okay, we will start by making an assertion, assert true, that our TDD set is an instance of the set interface. Okay, great. We execute our code and start the execution. Our test should fail right here because our TDD class is not a set yet. Okay, great, so our test is failing. We expect to have true, but we have false. So we go and implement enough code to make our test pass. So we create set, we implement the set interface. The set interface is accepting a generic element E. So we'd like also to have to have our set to be generic. So we could add it into our TDD set and implement what it needs to implement to be a set. Great. Okay, so if we execute our code, it should run successfully. Okay. Yes, so our test didn't pass, but it's not because we didn't write well our test, but because actually we forget to set up our TDD set. So we could right here just instantiating the TDD set, and it would work, but I'd rather delegate to Mockito the responsibility of instantiating that set. So I would say right here inject mocks, and I will annotate my class with like extend with Mockito extension. I would say Mockito extension class. Okay, so if I re-execute my code, it should run successfully. If you're using JUnit 4, you could like create the setup method and like calling Mockito annotation and init with this method. Okay, my test is running successfully, so I would like move to my next test. Let's say that we would test the simplest method that we have in TDD set. We could like start with testing the isEmpty method. Okay, so we could say with our test okay, void isEmpty method should return true when the set is empty. Great. Okay, we could write here to have a prettier name for our tests. We could add like some display names. I would add some display names to my tests. So I would say right here should implement the set interface. I would add another one right here. TDD set. Okay, and I would say the same right here. I would do the same right here. Display name is empty. Method should return true when the set is empty. Great. So to test this, we just like we could assert directly that our TDD set is empty. Okay, we execute our code and see if it's working. Okay, great. So we have a failing test. We should go and implement enough production code to make our test pass. So we could like fake this and return true, and it would make our test pass. Okay. Okay, great. So it's working. Let's do our next test. We like always write the display name first. Spread here, let's say empty. isEmpty method should return false when the set is not empty. Great. So like we type void isEmpty method should return false when the set is not empty. Great. Okay, to do this, we could like right here introduce the 3A principle. 3A principle, which is arrange, act, and assert. Arrange like preparing what we need as data to make our test. Act like calling the method that we'd like to test, and assert like a test, and assert like asserting the result. Great. So for arrange, I would like try to add an element. I would add an element. We could like fake this element right here. We comment later with the act command, the act step. We could like call the TDD set is empty. Okay, we could like put it in a variable. We should always right here follow the convention for isEmpty. We could like it should be always like is something. So we could like type it isEmpty, and we do the next step, which is the assert step. We assert that empty is like false. It's not empty because we already added something. Okay, I will execute my code, and it should fail because we didn't yet actually implement, because our isEmpty is always returning true. Okay, great. So it's failing. It expects to have true, but it has false. Expect to have a false, but it has true. So we should go and implement our isEmpty method. Okay, great. So right here, I'd like to have a discussion because I've seen some developers like starting developing this one with like creating a private attribute. They call it like isEmpty. Will like instantiate it to true because it's true from the beginning. They return an isEmpty right here, and when they add an element, they just isEmpty takes like just false. Okay, so if I execute this code, it would pass, but I'm not very happy with this solution. Okay, it passes, but I'm not very happy. Why? Because the problem with this code is that we are implementing a poorly designed solution. It's true that it's not enough to make our test. It's true that it's enough to make our test pass, but it needs to be refactored later. We should like later refactor this isEmpty attribute. Let's just take an example. We imagine ourselves like being in a team, treating the same class. The next developer would need to remember to refactor this class and remove that attribute. Okay, so we like right here talk about curing from a disease. A disease is like poorly designed code. Why? Because we created something that we need to refactor later, so it's like not designed well. Instead, we can work with a protecting driven way. So we could like implement enough and like correct code from the beginning that ensure a well-designed solution and that would not harm our design. So right here, that's why I'd rather go with implementing the add method to let my test pass, instead of creating like legacy code like the isEmpty right here, a legacy code that would be like removed later and like would harm my set design. Another reason right here is that our, let's say, solution right here is not open close. Why it's not open close? Because if we evaluate our code, we will be like removing this attribute, so we will be changing the implementation. It should be open for extension and close for modification. If we like write this attribute with a true, we would be like changing the implementation to evaluate our solution. So I'd rather create what it needs in the add method. I'd rather create the add method instead of like creating whatever code to make my test pass. So for this one, as a conclusion, with all my respect to all those who has created such solutions, I would say enough. The third one of Uncle Bob rule, the third one that says write only enough production code to pass the test, does not mean that we write like whatever to pass the test, but we should indeed writing the correct and well-designed code to make the test pass. So for that right here, I would rather create my array and create what I need in the add method to be able to make my test pass. Okay, to be able to add really an element. Okay, so elements right there. I would create like this element array. I would instantiate this element in my constructor. I would like say these elements take new objects and empty objects array. I will cast it to E right here, and I will like put right here suppress warning with like unchecked value. Okay, I would like return right here the real implement elements lab equal 0. Okay, and I would go to the add method. Instead of doing the isEmpty way, I would say I would take my element, resize it with the arrays API. I make a copy of the element and I just add 1 to the size of my elements. I should preserve this to like old length, sorry. Okay, old length, and I should go right there, going to elements, old length takes E. We could like change E to add, it's better, and fake the return type. Right here we faked the return type. This would not harm our design. But if I add like attributes, like beginning to add like fancy code to make my test pass, it would not like help me finish with a well-designed and well-written code. Okay, so I re-execute my test and make sure that it would pass. Okay, great. So it's executing, right? So right here we have like a warning that say unchecked call to add E, and that's because we didn't like specify the elements type, which is string. So we specify string and it and the warning is gone. We can like inline the TDD set is empty. In the assert false, we remove this, we remove the comments right there, and we like could assert also that our add method has been performed successfully. Okay, I would like wrap all of this in assert all method. Assert all method is like a method that enables me to see all the assertion results from the beginning. So it's like I would gain too much time if I use it instead of executing multiple time. Okay, I re-execute my code and check if it's working. Great, so it's working. Great. Okay, so as you remark right here, we have like a pattern that say isEmpty method should and isEmpty method should right there. Could we do something for this? I think we could. We could like create a nested class that takes, let's call it isEmpty method should, and like we could like add a pretty display name for this, which says isEmpty method should. We should use the nested of unit 5. We could like remove this one and like instead we remove all our on the additional code of that class. We could like remove the redundant code and the refactor. Okay, so our test would be like organize it right here, and we'll have what we need in terms of our test is well architected. Okay, we re-execute all our tests, and we would see that we would execute right here all our tests, and we would see if we break any test. Okay, so great. So we like right here we created a well-tested class with a good implementation that does not, let's say, that is not like designed poorly. We just created a well-designed code and we created a well organized test for our set. That would be all for this video. We would test the other methods in the next videos. Thank you.